Well, hello there. We're on lesson 2 of simplifying radicals. So, way to simplify radicals is by factoring them. So we're going to do some factoring. So in this one, we're going to write a radical expression before we work with it. So in this guy right here, we've got what we know is the door is W units wide and 3W units high. What we need is that diagonal length here. This guy right here, and we got to see, will that painting indeed fit through that window? See, who says you'll never use this stuff? They use this stuff in the art museum all the time. So you can look now and see, can I fit my older brother through that doorway? Math will let you know. So our plan is to use the Pythagorean theorem. So let's work through that. We know, let's build this together. So the Pythagorean theorem is going to tell me that d squared, which is going to be my distance or my length of my painting, is going to be w squared plus 3w, and I'm squaring the whole thing, and that's important to keep track of that. Do some simplifying here. I'm going to see that d squared equals w squared, and that's going to be 3 squared, which is 9, and I'm going to square that w. All right. Now I'm going to work through these guys. If I do the square root, I got to see how many. I got w squares all over the place. So it's going to be d squared equals, I have 1 w squared here and 9w squared there, so total 10w squared. Yeah. And then I'm going to square root them, and I'm going to end up with d equals, it is true, it's going to be plus or minus the square root of 10w squared, but we're not going to have a negative measurement, so I am not going to use the negative version of this. I'm just going to stick with the positive one. Keep it positive, ladies and gentlemen. So it's going to be the square root of 10w squared. The square root of w squared is w itself, and so my answer is w times the square root of 10. And that's the most I can simplify that radical, or the most I can factor out of that. All right, I want you to try it. The door height changed a bit. It changed a titch. Will you go ahead and solve this one out? Press pause. I found out that the diagonal of the doorway is w times the square root of 17. Leaving it as a radical. I know some of you like to get to that decimal version of it, but this way we're just working with radicals, so we're going to leave it that way. You can simplify some radical expressions using the following property, the division property of square roots. For example, over here, if I have the square root of 36 over 49, I can break it into the two pieces of square root of 36 divided by square root of 49, and get those square roots and end up with 6/7. So that is an option I can use. When a radical and it has a denominator that is a perfect square, it's easier to apply this rule first and then simplify it. When the denominator of the radicand is not a perfect square, though, it might be easier just to simplify the whole fraction first before you break it into pieces. So sometimes you might be simplifying this first before you break it into two separate radicals. So let's practice that out a little bit. So what is the simplified form of this particular radical here? So square root of 64. Square root of 64 over 49. So I'm going to break these into the two pieces because they are these nice perfect squares. Square root of 64 is 8. The square root of 49 is 7. So my answer is 8/7. B, this one's a little bit different. For this guy, 8 and 50, not perfect squares. But what I can do is I can simplify them by dividing both the numerator and denominator by a GCF, which I can see 2 goes into both of them, and an x. So I'm going to divide my numerator by 2x, which gives me 4, and x to the third divided by an x drops me down 1x, divided by 50, so half of 50, 25, and I have an x and I divided by x, which means subtracting an x, dropping it down 1. That x goes away, so I end up have the square root of 4x squared over 25. If I break these into the two pieces, I can see that this equals square root of 4 times square root of x squared over square root of 25. Ooh, this is looking pretty nice because square root of 4 is 2. The square root of x squared is x. And square root of 25 is 5. My simplified answer is 2x over 5. All right, I'm going to bring this up here. I'll leave my notes so you can take a look. I'm going to press pause and work out these 3 samples. All right, when I look at these samples, I can see that my 5a, I end up with 4, simplifies down to 4, 12 over 3. For b, I divided by the GCF, so I found 4a being that common factor. So looking for the square root of 9 over a squared. Well, the square root of a squared is a itself. Square root of 9 is 3. So I end up with simplified down to 3 over a. My last term here, I broke it into the pieces, square root of 25 and square root of y to the third. But y to the third is actually y to the second times y, because I'm looking for that even numbered square. So that allows me to factor it out to just that y. So I end up with 5y times the square root of y over z, because the square root of a square is itself. Let's do more. When a radicand in a denominator is not a perfect square, you may need to rationalize the denominator. And who doesn't like to do that? So let's talk about how you rationalize a denominator. Let's just play this out. So in this particular situation, where we have the square root of 3 over the square root of 7, you want to multiply both the numerator and the denominator by square root of 7. And by doing that, square root of 7 times the square root of 7, you get 7. And when you take square root of 3 times the square root of 7, you end up with the square root of 21. And I look at both of those, and square root of 21, there's no perfect square for me to factor out of that. So my answer for this one, when simplified, is square root of 21 over 7. So we don't want to leave a radical in your denominator. So tend to those. Let's look at another one, a little bit more complicated. Square root of 7 over square root of 8n. I'm going to go ahead and I can factor this out, so I want to do that. So square root of n squared is the square root of 4 times 2 times n. And I can factor the 4 out of there, so I end up with square root of 7 over 2 times the square root of 2n. All right, now I want to deal with my radical in my denominator. So I'm going to multiply by the actual radical itself. But I'm going to do it to both the numerator and the denominator. And when I do that, square root of 7 times the square root of 2n, I end up with the square root of 14n over, and I have 2 times the square root of 2n times 2n. I end up with, this ends up being like 2 times 2n, which is 4n. So let me rewrite this. So it's going to be square root of 14n over 4n. There you go. I'm wondering if I missed a step here. I mean, I see it, but I want to make sure you see it. So it's square root of 7 times the square root of 2n. It's how I got the 14n. So square root of 7 times 32n. Oh, goody. You have an opportunity to try this out. Press pause and give it a rip. All right, a couple of details to keep an eye on would just be as you factor these out, keep track of them. What's going on here? Notice for b, I factored out the 18 first before I multiplied my radical at all on this one, and did some combining of some terms on this one. Yeah. Just take some practice. They'll look funky until you get working through them for a while. All right. There you go. Keep practicing. You'll get great at it. I'm going to go and see if I can find some owl pellets and put them on my older brother's ice cream.